Today is our final notes topic for the entire year of Algebra 1, the quadratic formula. We're going to skip over the warm-up. This is looking at completing the square. No, this is looking at solving vertex form to see who solved it correctly. I'll leave that for you to look at. I'm going to go ahead to our flow chart, and we're going to fill in our final box. So our first four special cases, always the best things to look out for. Remember that linear factors, the area model, factoring, factorizing, whatever you call it, is basically changing to this form to simplify things. Solving by completing the square is changing to this form to simplify things. Our last resort, if nothing else works, is called the quadratic formula. It is the worst way to solve quadratics because it is the most prone to making little mistakes, like sign mistakes and adding mistakes and subtracting mistakes. There's a lot of ways to mess it up. So basically, everything else is a better choice, but this one will always work for every quadratic that you could ever see. So it's kind of like our last resort. If we can't do something better, then we're going to use this one. Now, hopefully just seeing the formula right here or on your star chart helps you see that it's not pretty. So we have negative b plus or minus b square root of b squared minus 4ac all over 2a. You probably picked up on a, b, and c here are going to match up with our standard form coefficients. So you can use this, but it has to be in standard form, has to be set equal to 0. And then you have to keep track of all of these, this sign, the square root, and simplifying it. These numbers might get really big and hard to deal with underneath a radical. So yeah, there's a lot of little things in here. Before we move on to explaining how to use it and doing an example, I want to kind of break it down to help you see what we're doing here. So really, there's two parts to this formula. The one on the left is negative b over 2a. The one on the right is plus or minus the square root of b squared minus 4ac all divided by 2a. So you probably recognize the part on the left as being the axis of symmetry. So if you think about what this formula is doing, it's saying, okay, your axis of symmetry is here. Now the plus or minus is how far to go left or right to find your solutions. So yeah, you could rearrange vertex form or even standard form, but vertex is easier. Basically, if you did standard form and apply completing the square to it, then you would end up with this formula, and that's how it comes about. It's kind of a brute force way of solving a quadratic with completing the square, and then you get this result. So we find our axis of symmetry, and then we find out how far away to go to find the zeros. If we end up with a negative radical, as usual, that means there are no real solutions, meaning that the parabola turns around before the x-axis, and then we don't have any x-intercepts or real solutions. So hopefully that helps you frame it a little bit, is that this is negative b over 2a, and then this distance is the square root of b squared minus 4ac divided by 2a. So we have the AOS, and we have the distance away to the left and the right that we find our zeros. Okay. If you want an activity to do, an exercise, take this and try to solve it by completing the square. You'll end up with this. Here it says, note, pay attention to signs. Like I said, there's a lot of ways to mess this up. You got to be really careful and only use it if you have to. So step 1, rearrange into standard form. Step 2, which it doesn't say, is you should still look for a GCF, because making a, b, and c smaller is going to make the numbers inside of the formula smaller. So divide out GCF. Here we don't have one, so we don't need that step. We have 3x squared minus 4x equals negative 4. We're going to put 3x squared minus 4x. We're going to add 4 to both sides. and get plus 4 is equal to 0. So step 1 is done. There's no GCF to divide out. Identify A, B, and C. So A is 3, B is negative 4. Remember the sign has to go with it. And C is positive 4. Then we're going to plug everything in where it goes in this formula. So we'll just follow the formula. So this is negative B. So we're going to put negative 4 plus or minus B squared negative 4. The whole negative 4 gets squared, so it'll become positive no matter what. Minus 4 times A times C. Those are all multiplied. Over 2 times A. Once we've put everything where it goes, now begins a lot of simplifying and making sure we keep track of all of our numbers. So our negative 4 becomes 4. As usual, I like to think of this instead of as negative b, as I try to think of it as the opposite of b. So when I see negative in a variable, I always try to think of it as the opposite of that number. That way I don't have negative 4, I have the opposite of negative 4, which to my brain makes more sense as that being just a regular 4. Then we have plus or minus, because we need a solution to the left and the right. The square root of negative 4 squared. Remember, we're squaring it with the negative, so we get positive 16. This number here will always be positive because it's a perfect square, and perfect squares are always positive. Minus, here we have 4 times 3 times 4. Now, this is a big place that we mess up our arithmetic. So I've kind of found it easiest to think of this when I do the formula as minus 4 times AC. And I go ahead and multiply A times C here instead of putting 4 times A times C. That way I don't have a string of 3 things being multiplied together. I just have a coefficient and a thing I'm multiplying it by. So here we'll have minus 48. And then all of this is divided by 2 times 3, which is 6. The next step, A and C are positive. So the next step is to say I have 4 plus or minus root negative 32 over 6. And we know that with any of these methods, anytime we see a negative result under a radical, we put no real solutions, and that ends the problem. We don't do anything beyond that because we don't know about complex numbers yet, and we can't simplify a negative radical. So we stop there. These feel tight on space, so I'm not going to write out quite as much. I'm just going to say this is A, B, C, and label it here, rather than like writing A equals B equals C equals. So our formula says the opposite of B plus or minus the square root of B squared minus 4 times AC. AC is 5 times negative 1, so negative 5. Divided by 2A, which is 10. So here, this is going to become positive, so we'll actually have real solutions this time. 2 plus or minus the square root of 4 plus 20 is 24, divided by 10. Now we can simplify the radical. So now that we've simplified what's underneath the radical, we need to simplify the radical, and we can do that as 24 is 4 times 6, so this gives us a 2 on the outside. So we get 2 plus or minus 2 root 6 over 10. Our last step, did it say here? Yeah, so this is underlined in bold for a reason. This is one of the most common mistakes in all of high school math. So number 1 most common mistake is perfect square trinomials and knowing how to square binomials and knowing that there's a middle term when we do that, the 2AB part. Number 2 most common mistake in all of high school math is simplifying fractions that have multiple terms in them. So think about if I had 4x plus 6 divided by 8. So this mistake that's very, very common, so you have to be careful because it's so common, is to simplify the to simplify the 4 and the 8 and make this 1 over 2. The problem with that is you simplified only part of it. So it's like it's a distribution error basically, because 4x plus 6 over 8 means 4x over 8 plus 6 over 8. And you simplified the 4 over 8, but not the 6 over 8, and it just magically is now 6 over 2. You changed its denominator without shrinking it accordingly. So if you're going to simplify a fraction, so let's put no here, and then let's do it correctly. So here we would do 4x plus 6 over 8, and we need to simplify all 3 of these because the 8 distributes to both of these. So this would become a 2. We can divide them all by 2. We have to write it back. 2, this becomes a 3, and this becomes a 4. So all 3 of them have to simplify together. You can't just simplify 2 of them. Yes, I should have done that all in green, but whatever, I'm not going to go back. So be very careful of this, because we have that exact situation built into the quadratic formula, and this is a very common thing that gets messed up. So I have a 2 root 6, and a 10. All 3 of those are divisible by 2. So my answer here would be x equals 1 plus or minus root 6, which is, remember, 1 root 6. We don't write the coefficient, over 5. So we downsized or reduced all 3 numbers in our fraction by a factor of 2. So we divided all of them by 2. I'm going to make a note here. Divide all 3 by 2. So another spot in here that's easy to make mistakes. So you can make mistakes with the original formula, so the negative b, common mistake. Squaring b, common mistake. Negative 4ac, common mistake. Bottom, most common mistake here is putting a instead of 2a and forgetting the 2, but it's on the star chart, so you shouldn't forget that. Simplifying the numbers underneath, like just adding the 2 numbers together, really common mistake. Simplifying the radical, fairly common mistake, but not that bad because simplifying radicals is something we practiced. And then finally, simplifying the fractions, very common mistake. So we have 5 or 6 pitfalls, very easy places to make mistakes when using this formula. So that's why we recommend using it as a last resort and not as a way to do all of them. It's not a good default method at all. Okay. Next one, we're going to go through these a little bit faster. That was our main example where we didn't end up with no real solution, so I wanted to make sure we spent a lot of time talking about how to simplify the fraction, how to deal with all those common mistakes, and what to be careful of. This one we'll do faster. So we have a, b, and c. Negative b is 9, plus or minus the square root of b squared is 81, minus 4 times ac is negative 10. All divided by 2a, which would be 4. One thing we haven't seen, that we don't have in any of these actually, is if there's a negative a value. If there's a negative a value, then we would end up with a negative in the denominator. Just a reminder, we don't ever leave a negative in the denominator. We always move it up to the numerator. So on the next one, we'll force it. We'll change it so it has a negative. Okay, so we have 9 plus or minus that. So 9 plus or minus 81 plus 40 over 4. 81 plus 40 is 121. So 9 plus or minus. The square root of 121 is 11. That's a perfect square. So any time that we end up with a perfect square, 9 plus or minus 11 over 4. That's a clear indicator that this was not the best method to solve this problem. Because if it doesn't have a radical in the answer, that means you could have solved this by factoring. So you should have solved this by factoring. In fact, I should have looked for that, but I was just trying to default to using quadratic formula. But yeah, so we have 2 times negative 5. So we need a number that makes 10 and makes 9 by subtraction, which is just 10 and 1. So definitely should have solved this by factoring. Now we have 9 plus or minus 11 over 4. That's not an acceptable final answer because this is rational. So we need to do our branched reality thing and make it 9 minus 11 would be negative 2 over 4, or 9 plus 11 would make it 20 over 4. So our x equals, the negative answer is negative 1/2, and the positive answer is 5, which definitely is answers that we should have come to by factoring, not by quadratic formula. This one, let's change this. Actually, an easy one to do would be the first one. Let's go back and change this slightly. Since we had no real solutions, all we need to do to make it have real solutions is throw a negative in the front, because that would reflect it. So if it had no x-intercepts and we reflect it, now it will have x-intercepts. So let's redo this same problem, but with solutions this time. So we're going to do negative 3x squared minus 4x plus 4, not changing anything else except making a negative to reflect it. Okay, so now we're going to plug into this formula. The opposite of b is opposite of b is 4 plus or minus the square root of b squared is 16 minus 4. This time a times c is a negative 12. All divided by 2a is negative 6. So I wanted to do this example to show you how to handle this negative on the bottom. Since there's a negative here, we actually want to put it on top. So I'm going to put the negative here and get rid of that one. Now you may wonder what happens to this. So this says plus or minus, but if I make it negative, that doesn't matter because I already have a positive and a negative option. So the negative doesn't actually impact that at all. So I don't need to worry about like distributing it to both pieces. It just goes with the 4, and then the plus minus is still plus minus. Okay, now we can simplify this. We have negative 4 plus or minus the square root of 16 plus 48 all over 6. That makes 64, which is a perfect square, meaning once again, this one should have, now that we fixed the sign, this one should have been solved by factoring. Okay, negative 4 plus or minus 8, all divided by 6. That means our two answers are negative 4 minus 8 over 6, or negative 4 plus 8 over 6, which simplifies to negative 2 or positive 2/3. But yeah, that's way more work and way more chances to make mistakes than if we had just factored it. That's pretty much covers quadratic formula. If you want to try some of these on your own, I'll do a few more just to have, if you're not feeling comfortable yet, just to have a few more examples in the notes video. But really that covers everything that we need to talk about. So if you want to move on and try on your own, go for it. Okay, this one I'm going to check. 4x squared minus 3x minus 1 is equal to 0. So we have a negative 4. Yeah, that factors because we can do 4x and x. And then we need to make 3. We need a 1 and a 1. So if I do a plus 4x and a minus 1x, oh no, the other way. We need a minus 3. If we do a minus 4x and a plus 1x, then we get x is equal to negative 1/4 or positive 1. And that is the easy way to solve that. Do not do quadratic formula for that. So here we have a 6, and by addition, we need two factors that make negative 1. Obviously, there are no factors of 6 that can create negative 1 by addition, right? They have to make a number bigger than that. So that means this could be done by quadratic formula because it's not a good candidate for completing the square. So let's go ahead and do that. So the opposite of b is positive 1 plus or minus the square root of b squared is 1 minus 4 times ac, that's 6, over 6. Now, looking at my radical, I have a negative 23, so this has no real solutions. I don't need to finish the work of simplifying stuff since my answer is already known. In this one, we have a negative 30, so we would need two factors of 30 that make 3 by subtraction. I don't think there are any. So we have 310, that's a difference of 7. We have 5, 6, that's a difference of 1. So yeah, no way to make that. So we've got quadratic formula appropriately solved with quadratic formula. So we have negative, or the opposite of b is 3 plus or minus the square root of b squared is 9 minus 4 times ac is negative 30. That's a big number. Divided by 2a, which is 12. 9 plus 120. So we have 3 plus or minus the square root of 129 over 12. I don't actually know if 129 simplifies, so let's see. I know that since the digits add up to a multiple of 3, that it can divide by 3. That makes 43. 43 should be prime, so that means we can't simplify that radical. Now, since we can't simplify the radical, here's that trap that I want you to watch out for. We can't simplify the 3 and 12 because our three coefficients are actually 3, 1, and 12. So there is no way to simplify this fraction because 3, 1, and 12 don't have anything that we can simplify them by. So that's actually the finished answer here. There's nothing that can be simplified. Can't simplify the radical, can't simplify the fraction. This one has stuff on the wrong side. So we have 4x squared minus, when we minus the x, they cancel. So we actually have 4x squared plus 5 is equal to 0. Now, we should recognize this as one of our easiest methods to solve because b is equal to 0. So we should solve this by inverse operations. 4x squared equals negative 5. X squared equals negative 5/4. And then we square root a negative, meaning there are no real solutions. I'll leave these as extra practice for you to do. You can check them with the key on Canvas, but hopefully you've got the idea. Quadratic formula, you just plug the numbers in, but then there's a lot of places to mess it up. So it's simple in like concept of just you need this and it's on the star chart and you plug in the numbers. But as you work on it and practice it, I promise you there's a lot of stuff that you'll screw up on it. It's very, very error prone. So that wraps up our final method of solving. Remember to follow the flowchart. Try to find these easier methods first and leave the harder methods for cases where you have to use them.